Another application of differentiation is the rate of change. A good example of the rate of change would be, for instance, a tank that is being drained. The rate that the liquid will run out of the tank will change depending on the volume of liquid inside of the tank. At the beginning, it's going to run out more quickly since there is more pressure in the tank, and the more empty the tank becomes, the slower the liquid will run out of the tank. We can use a function notation to express things like this. For instance, the volume of the tank depends on the time that the water is running out. The more time passes, the slower the volume, the rate of the flow will be, and the volume will become smaller. I'm going to do example 1 on page 133. It says that the oil tank is being drained, and the volume of the tank is liters of oil that remains in the tank after a certain amount of minutes. So they ask us to compare the average rate of change of the volume during the first 8 minutes and also during the last 8 minutes. Now the average rate of change is similar to the average gradient, which we already calculated using a very familiar formula. However, in this calculation for the average rate of change, we are going to work with the volume and the time. We first need to calculate the volume at the beginning of the experiment when the 0 minutes have passed. So we'll substitute the time with a 0. This is the volume inside of the tank. And after 8 minutes, we will substitute the 8 to find the volume at 8 minutes. Now we will calculate the average rate of change. The volume at 8 minus the volume at 0 divided by 8 minutes minus 0 minutes. Substitute the values, and the rate of change is negative 2,400 liters per minute. The negative is showing us that the tank is becoming more empty, the volume is decreasing. We will do the same calculation to find the average rate of change during the last 8 minutes of the experiment, and that means that we will calculate the volume after 16 minutes, which is 0, the tank is empty, and the volume after 8 minutes we already calculated previously. I'm going to use the same formula to calculate the average change during the last 8 minutes. The volume at 16 minus the volume at 8 divided by 16 minutes minus 8 minutes. When I calculate this total, I can see that during the last 8 minutes, the average rate at which the tank is being drained is negative 8,000 liters per minute. So we will notice from these two results that at the beginning, the rate of the flow was higher than during the last 8 minutes.